means the same degree over same degree. It is indeed type 1. So what do I know about this and what is so special about it? It's because the horizontal asymptote is the leading coefficient over the leading coefficient. That's characteristic to degree 1 over 1, 2 over 2, 5 over 5, 10 over 10. Same degree over same degree. The horizontal asymptote is the leading coefficient over the leading coefficient. I get my table started. Negative infinity to infinity. I already have the answer. Y equals 4. I don't want to write it there. I want to write it underneath. I want to write 4. Just 4. And underneath it, y equals 4. So this is y equals 4, horizontal asymptote, and 4. So we already have the horizontal asymptote. I'm going through my list. I kept it from last class. So I already have the end behavior and the horizontal asymptote. That is done already. Moving on. Where is this function undefined? What x value? We can never plug in this function because we're not going to get an answer. Very good. So 0 has to be in the middle, and 2 is to the side of right-hand side of 0. And this means that I cannot put a number underneath 2. I will write that x equals 2 is automatically a vertical asymptote. And my next step immediately will be writing infinity and infinity. I don't know the sign. So I'm not going to put this in the table, but up here I can. Two numbers very close to 2 from left and right. When I plug in 1.9, this will be negative and this will be positive. Positive over negative, what sign will this infinity have? Very good. Now I plug in, or imagine that I plug in 2.1. 2.1 minus 2 will be a positive number. The top is 4 times 2.1. Positive over positive. I found the sign.
Positive.
Done. So what have we accomplished? A lot. We have the end behavior, which is characteristic to same degree over same degree, leading coefficient over the leading coefficient. We have the vertical asymptotes and the function behavior left and right of the vertical asymptote. We also have the domain. Now we want the x-intercepts. Potential holds none. I'll explain. We'll get an example about this in a moment. X and y intercepts. We're done. I have to plug in 0. 0 over negative 2 is 0. And there is no other intercept because when x is 0, y is 0. When y is 0, x is 0. This is it. So the origin is the x and y intercept. Done. That's all I need. So let's graph it. Yes, you can find as many ordered pairs as you want, but I'm ready to graph. When I graph a function with asymptotes, I have to start by graphing the asymptotes. It's a must. This function has at 2 a vertical asymptote, and it has at 4 a horizontal asymptote. Now I'm ready to plot. I have the origin, and I'm only looking, I just need another prop here. I'm only looking to the left-hand side of the vertical asymptote. From approaching the horizontal asymptote, crossing at the origin, going towards negative infinity. From approaching the asymptote, crossing at the origin, and coming down to negative infinity. That's it. Do not touch the asymptotes. On the other side of the vertical asymptote, it's coming from positive infinity, coming back to down to 4. And this is the graph of function f of x equals 4x over x minus 2. What about the range now? Can anyone give us the range of this function? So the x and y intercept, there are no max min, the range, and no potential holes. Everything was done. I don't want you to spend more than tops 3 to 5 minutes on this type of problem. I couldn't hear, or I'm deaf. I hope I'm not deaf. Do we know the range?
Negative infinity to 4, union 4 to positive infinity.
That's it. Very clear. From negative infinity. Oops. That's it. Type 2 is even easier than type 1. So let's move on to type 2. Let me push this further away from me. So I don't have room for my papers here. Okay. Let's look at type 2. Type 2 is when the denominator has a higher degree. Can anyone choose? Can anyone choose a type 2 from 57 through 80?
59.
59 it is. 59. Perfect. Very good. Indeed, we have f of x equals 2x over x squared minus 4. And since these are always in the back of my mind, of course, I'm going to factor the denominator. X plus 2 times x minus 2. I'm going to get my table going. So can anyone give us the domain of this function? If you use this table or a table that you invent and all the information is here, you don't have to write it on the side for me. I get it. The more summarized, the better. Can anyone give us a domain for this function? That's why I factor the denominator, to make it easier on you. Anyone?
Negative 2 and 2.
Yes. So negative 2, 0, and 2. Okay, then. I will plug in negative 2.1, negative 1.9, 1.9, and 2.1. I'm not going to use them to graph. I'm just going to use them to find the sign of the infinity. So when I plug in negative 2.1, this is negative, this is negative, this is negative. 3 negatives. Clear. When I plug in negative 1.9, negative, but this is positive now. Okay, so it's positive. When I plug in 1.9, the top is positive, the denominator is positive, but this is negative. So negative. And finally with 2.1, positive, 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 positive. So going back through our list, which I'm going to add one item here today, symmetry. Okay, going through the list, I have the vertical asymptotes and behavior. I have the domain. These two are done. Now I'm going to talk about the end behavior and the horizontal asymptote. The easiest possible, type 2 always has y equals 0 as the horizontal asymptote. Always. Why? Because at infinity, this the denominator is so much more powerful than the numerator, they will eventually be 0. Good. Plug in 0. 0 at the top, -4 is 0. F of x is 0, y is 0. Now I wanted to talk about symmetry. Remember, there are two possibilities. F of -x to be identical f of x, or f of -x to be the opposite of f of x. That's what we studied this in chapter 2. So this is even, and this is odd. Well, here's what happens when I plug in -x. The denominator stays as is, because when I plug in -x in x squared, I don't get any change, -4. And this becomes the opposite of 2x over x squared minus 4, which is an odd function. This is the only thing that does not fit in my chart. Just going to write it on the side, odd function. As a reminder to make sure that I graph symmetric with respect to the origin. Okay, done. Let's graph it. All I care about is my table. Nothing else matters anymore. I summarized all my information in one spot. So okay, so asymptotes always first. They are not part of the graph, but they have to be graphed. So this is x equals -2, and this is x equals 2, and this is an overkill. There is no need to do this because it's the x-axis. Ready to graph? The table is telling us what to do. So here it is. 0, and then dropping to -infinity. I don't care for anything else. I'm only looking to the left-hand side of the first vertical asymptote, from 0 down to -infinity. This piece is done. Between the asymptotes, it's coming from positive infinity, it's crossing at the origin and going to -infinity. Now I don't care about the rest. I'm right here, to the right-hand side of the vertical asymptote from positive infinity to 0. And this is f of x equals 2x over x squared minus 4. Can anyone give us the range? Well, in this case, it appears to be everything. I didn't have to say, oops. It appears to be everything. Look. This is type 2. And of course, type 3 will be the most difficult one. But before we move on to type 3, I want to choose a function myself or create one because I don't see. Do I see one? No, I don't see one. Oh, I do see one. Yes, I do. 74. On the same page. What is it? 427. Okay, so that function is x minus 3. And then we look at it at type 3. Last one. Let's see how I'm with time. 14 minutes, that's good. Okay, so obviously I'm going to factor immediately. And I'm going to get my table started, and I have a few questions for you. What type is it? Is it type 1 with same degree over same degree? Or is it type 2 in which degree at the bottom is higher?
Type 2.
Type 2.
Indeed, it is type 2. What do I know about type 2? And I'm not going to waste a minute. This is what I know about type 2. I'll do it right away so I don't forget. Next thing that I see is, and I have to continue with the denominator. I cannot touch this. I cannot simplify before I write the domain. And then we'll talk about it. So what is the domain of this function?
-3 and 3.
Good. So we have to exclude -3 and 3. They are excluded. However, right now I cannot rush to write x equals -3 VA, x equals 3 VA. Why? Because I can do this. I stated the restriction first. I cannot simplify before I state the domain of the raw function. But look, this function changes into 1 over x plus 3. This factor stays, which means it is a vertical asymptote. But this factor, although the function is not defined there, it's not a VA, but x equals 3 gives a hole in the graph, or creates. You don't have to write, this is the first time we write it, we don't have to write, it's just a hole, that's enough. So here, I immediately write this, but here I cannot. I have to simply plug it in. 3 plus 3 is 6. 1 over 6, 1 over 6. So next, I do have to plug in our close numbers, like -3.1 and -2.9, right here in the simplified form. With negative, yeah. With -2.9, okay. So in the span of a minute, maybe a minute and a half, here's what we accomplished. Potential holes, and behavior, vertical asymptotes, domain. All this was done. There are no x-intercepts because a fraction is 0 only when the top is 0. But I have to plug in 0 and get 1/3. That's it. We don't have anything else. There is no talk about symmetry. If a function has a vertical asymptote on this side and a hole on the other, it cannot be symmetric. Here, look, see, even the horizontal they have to be. Vertical asymptotes are symmetric. If I have a vertical asymptote here and one here, the function cannot be symmetric. But even the vertical asymptotes were asymmetric. But here, that's not possible. I can write not symmetric right away. That's all I need. Now let's graph. Which page am I on for? How am I with time? Perfect. 18. Okay. So let's graph.